Good morning everyone, I am Avishek Mazumder and today in this video lecture we'll be covering the topic how to find the oxidation state of an element in a molecule. Okay, so now there are a few rules which you have to keep in mind while assigning the oxidation state to any element in a molecule. Now these are the rules which you have to keep in mind. The first rule is the free or uncombined state is always 0. That is, if we take a molecule like S8 or O2 or Cl2, so the oxidation state of sulfur in S8 will be 0. The oxidation state of oxygen in O2 will be 0. The oxidation state of chlorine in Cl2 will be 0 because these are the free or uncombined state of those elements. Now the next rule is to say that ions of only one atom, the formal charge will be equal to the charge itself. Like if we have ion Na plus, so the oxidation state of sodium in Na plus will be plus 1. If we have Mg plus 2, since this is a single ion, the oxidation state of magnesium in the Mg2 plus ion will be plus 2. If we have Cl negative ion, the oxidation state of chlorine in Cl negative 1 will be minus 1. Okay, now let's go to the third part. Fluorine, being the most electronegative element, will always have oxidation state of minus 1, no matter with whom it is bonded to. Hydrogen has plus 1 except when metal hydrides. Now for metal hydrides, we have the case like sodium hydride, NaH, or lithium hydride, LiH. In such metal hydride compounds, the metal ion comes with the state of plus 1 and hydrogen gets the oxidation state of minus 1. Okay, now let's go to the next point, which is oxygen has minus 2 oxidation state except when bonded to fluorine or in peroxide or superoxide forms. Oxygen bonds to fluorine in the forms of OF2. Okay, so in OF2, the oxidation of this is the priority. So fluorine always has minus 1. So the oxygen will always have oxidation state of plus 2. So this is the case. Also, peroxide forms involve like H2O2, 2O2 or Na2O2, 2O2. In such cases, we saw that except for metal hydrides, hydrogen always has an oxidation state of plus 1. So in this case, oxygen will have a oxidation state will have oxidation state of minus 1 instead of the usually expected minus 2. Metals always have plus 1, so oxygen will in this case will also be equals to minus 1, the oxidation state of oxygen. Now the last and the most important point is also superoxide like KO2 or rubium oxide RbO2. Now potassium always has a oxidation state of plus 1. So in this case, oxygen will have a oxidation state of minus half. Similarly, in this case, rubidium always has oxidation state of plus 1. So oxygen will have minus half. This is the case of superoxides. Now let's go to the last point, which is algebraic sum of all oxidation states is 0 or equal to the charge on the polyatomic ion. Now this is the most important point. Now let's take an example like we get KMnO4, potassium permanganate. And in this we are asked to find the oxidation state of manganese. Okay. We use this point first. The algebraic sum of all oxidation states is 0 or equal to the charge in case of a polyatomic ion. Now since this is not a polyatomic ion, the algebraic sum of all oxidation states will be 0. Okay. So let the oxidation state of manganese be X. Okay. So the oxidation state of potassium is always plus 1. And since this is neither bonded to fluorine, nor is it a peroxide nor a superoxide, so the oxidation state of oxygen will be minus 2. So what we do is plus 1 potassium plus X, which is of manganese, plus, since there are 4 oxygen involved, 4 into minus 2 will be equal, since it is a neutral molecule, it will be 0. So we get x plus 1 minus 8 equals to 0, or x equals to 7. So the oxidation state of manganese in potassium permanganate is 7. Now let's take another example. Let's take, we have to find the oxidation state of chromium in Cr2O7 2 negative, the dichromate ion. Now, since this is not a neutral molecule, this is actually a polyatomic charge, polyatomic ion. So by the 6th point, we know that the net sum will be equals to the charge itself, which is minus 2. Let the chromium have a formal charge of X. Now oxygen, since it is neither bonded to fluorine, nor is it in peroxide form, nor is it in superoxide form. So, since 2 chromium atoms are there, so 2x plus, oxygen has a formal charge of minus 2. So, minus 2 into 7, since there are 7 oxygen atoms involved, equals to minus 2, which is the charge on the polyatomic ion. So, we get 2x minus 14 equals to minus 2, or 2x equals to 14 minus 2, which is 12, or x equals to 6. So in dichromate ion, the oxidation state of chromium is plus 6. Now let's take another example, Tl2O. Now in this we have to find the oxidation state of Tl. Let it be X. Now since this is not a polyatomic ion, so the net sum of all formal charges will be 0. Okay. So since oxygen is neither bonded to a fluorine atom, nor is it in oxide, peroxide or superoxide form, so since oxygen will have a formal charge of minus 2. So we have got, let the oxidation state of Tl be X. So since 2 atoms are involved, so 2x of Tl minus 2 equals to 0. Minus 2 comes from the oxygen part. So we can write 2x equals to 2, or x equals to 1. So the oxidation state of Tl in this molecule is plus 1. Let's take up another simple example, Fe2O3, or the ferric oxide ion. Now since it is also not a polyatomic ion, so the net charge, sum of all oxidation states, should be 0. In this we have to find the oxidation state of iron, so let it be X. Now since again it is neither bonded to fluorine, nor is it a superoxide nor a peroxide, so oxygen will always have a charge of minus 2. So let oxidation state of iron be X, and since 2 atoms of iron are involved, so 2x and plus oxygen has an oxidation state of minus 2, so minus 2 into, since 3 atoms of oxygen are involved, so 3 equals to 0, which is the, since it is a neutral molecule, so the algebraic sum of all oxidation states is 0. So we can write 2x equals to 6, or x equals to 3. So the oxidation state of iron in Fe2O3 is plus 3. Now let's go for the last example, which is MnO2, manganese dioxide. Okay. So since it is a neutral molecule, so the sum of all oxidation states will be equal to 0. Now since again oxygen is neither bonded to fluorine nor a superoxide nor a peroxide, so it has an oxidation state of minus 2. So let the oxidation state of manganese be X. Therefore, we can write, since only one manganese atom is involved, so X plus minus 2 into, since 2 oxygen atoms are involved, so 2 will be equals to 0, or X will be equals to 4. So manganese has a formal oxidation state of plus 4 in MnO2. So I hope this video lecture was useful in solving all your doubts on this topic. Thank you.